Kiddos, I am home with a sick kid today, so you are starting this new unit on your own. We're talking about quadratics and polynomials. So today we're going to talk about some new vocab words, finding zeros, finding the vertex, the GCF, that is the greatest common factor of a binomial. We talked about those words, binomial, I was pretty sure, maybe not. So we're gonna find the zeros and the vertex of a quadratic equation written in standard form today. So first thing that you're gonna do are these warm-up questions, okay, where you're going to use the distributive property. I'm having you do this because factoring is what we're headed towards, and factoring is the opposite of distributing. Okay, so you're going to write these in your notebook, the notebook that we get to use on our open note quizzes, friends. Open note quizzes. So these three warm-up problems, let's do them. The first one, I'm going to distribute the x to both pieces. Okay, x times x is x squared. X times negative 4 is negative 4x. Next one, 3 times x is 3x squared. Way back from our exponent unit, we know that x times x is x squared. 3x plus 8 is 24x. And the last one, I'm going to get negative, and then 2 times 4 is 8. X times x is x squared. Here's where I'm going to get positive because I have a negative times a negative, and I get positive 2x. Okay, please make sure that you can distribute properly. Why we are distributing once again is because factoring is moving backwards, and all of these have a GCF. So today I'm going to give you this problem, and you're going to give me this as my answer. So x squared and negative 4x have a GCF of x. They both have an x in them. When I think about this one, 3 and 24 have a GCF of 3, and x squared have a GCF of x, and I move backwards. Okay, so that's what's headed for us today. All right, standard form. Standard form is when we think about ax squared plus bx plus c. That's what standard form means. If you'll notice, a, b, and c are coefficients. Okay, that's the number in front of a letter. And then these go in order where the first term has x squared, and then the next term has x, and then the next term doesn't have any x at all. Okay, this is the standard form of a quadratic. I should have put that in there. A quadratic is an x squared function, right? And we call the name of the shape it makes a parabola. The U shape, and I put this funny picture here, right? They kind of, I don't know. The U shape that the graph makes. It is not a V, it is a distinctive U, and it's either a right side up U where you're smiling, or an upside down U like a frown. Okay, parabola is the U shape that it makes. Vertex is the turnaround point right here. This is the vertex. Oops. The turnaround point. Okay, it's the it is halfway between the zeros. Okay, zeros are also known as x-intercepts, also known as roots. I don't know why we have three names for them. Basically, today I'm going to ask you to sketch me some parabolas. And when I ask you to sketch the parabolas, you are going to find the zeros, and you're going to draw them on here. They are x-intercepts. Okay, they land on the x-axis. You're going to find the vertex. It'll be halfway between them. And then you're going to draw a U shape that has two arrows on the ends. Okay, so when I'm asking for a sketch, this is what I'm asking for. I'm not asking for a perfect picture. I'm asking for you to find the zeros and plot them on a graph appropriately, to find the vertex, plot it appropriately, and then draw a U shape. Okay, remember to pause when you need to pause. If you need to pause now and take notes, hit the pause button. All right, so here's our first example where we have to factor and find the GCF of 7x squared minus 42x. I have some steps written here for you. The first step says set equation equal to 0. So instead of this f of x, right, which we also know we can replace it with a y, I'm going to write 0 equals 7x squared minus 42x. Okay, that is step 1. You set it equal to 0. Step 2 says take out the GCF. So I've got different things here. I've got 7, and I have x and x. I'm pretty sure we've done this. I'm feeling like I blocked a bunch of this out, but I know that we've done it. 42 is negative 7 times, I hope it's 6, and x. Okay, and when I look at this, I have a 7 and an x and a 7 and an x in both of them. Okay, so that is my GCF. I'm going to take a 7x out of my, and it's like dividing. Okay, so when I think about 7x squared divided by 7x, what I'm left with is just an x. I put a parenthesis here. And when I take out the 7 and the x out of the second half, I'm left with the negative and the 6. Okay, and those go inside the parenthesis. Okay, so remember, this is like undoing what I did before. On the first slide, I distributed. Now I'm undistributing. How could you check your work? You could redistribute. Okay, these are called my factors. 7x is a factor, x minus 6 is a factor. Then I'm going to set each factor 0 to 0 and solve. So for example, I'm going to write 7x equals 0, and I need to solve for x, so I'm going to divide by 7, and I get x equals 0 divided by 7 is 0. Okay, this is a 0. And then I'm going to do this one. X minus 6 equals 0. And I get x equals 6. Okay, these are my zeros. They are called zeros, they are called roots, they are called x-intercepts. These numbers need to go straight onto this. They just get plotted like this right here. Of course, when I was going to say, of course I put the graph on and it didn't have a 6. It does have a 6. You guys know where the stamp is if you need it. I think it's on my desk. Please don't abuse the stamp. I think I'm out of Post-it notes that have graph paper on them. Okay, how about the vertex? How do I know where the vertex is? The vertex is halfway between these two things. So what is halfway between 0 and 6? This one's not too tough. That's x equals 3. You can just find the average. Okay, we can add 0 plus 6 divided by 2 equals 3. That's my x value. To find my y value, I need to plug it in up here. This I'll probably use my calculator for. Okay, so if I say y equals 7 times 3 squared minus 42 times 3. I was doing some pre-calc, so I have the graphing calculator up. I don't need to do that right now. Desmos will work fine for you. The scientific, where is it? Oh, it's way down here. Y equals negative 63. Okay, so that's way, way, way down here. So here's 3. Let's pretend negative 63 is way down here. All you're going to do is take your pencil and draw the best U shape that you can. Mine always look perfect, of course. As you can see, I should have been the art teacher. They have arrows at the end. How can I verify? I had 7x squared minus 42x. I must have done something wrong because, oh, nope, I did it right. There it is, 63, negative 63. Here is my graph. You can pinch and pull. And look at my zeros show up on here too, 0, 0, and 6, 0. Okay, so what is your goal for today? Your goal for today are these 3 steps. You take this, you set it equal to 0. You factor out a GCF. You use those 2 factors to find the zeros. You're going to put them on the graph. Then you're going to find the vertex halfway in between and sketch. Okay, let's do another one. Step 1 is to set it equal to 0. Okay, step 2, I'm going to write this out. 3x squared is 3 times x, and 15 is 3 times 5 times x. Okay, they have a 3x and a 3x. 3x is my GCF, and I put a parenthesis. I have an x left, a plus, and a 5. Okay, these are my factors. After that, the next step was to set them equal to 0 and solve. So I write 3x equals 0. Okay, x equals 0 because 0 divided by 3 is 0. X plus 5 equals 0. X equals negative 5. Okay, put those right on your graph. Here's negative 5. Here's 0. Okay. To find the vertex, I need to go halfway between 0 and 5. I'm going to find the average. Sorry, 0 and negative 5. So 0 plus negative 5 over 2 is negative 2.5. You can use a calculator for that. Let's plug that in to find the y value. 3 times negative 2.5 squared plus 15 times negative 2.5. Get my calculator up here. Remember that this goes in parentheses. And I get that my y is negative 18.75. I don't really know where that is, but I'm going to do my best. This is negative 3, so negative 3.5, and we'll pretend negative 18.75 is way down here. And we'll just do a nice little sketch of that. So one last thing I want to talk about is when you have a negative leading coefficient, like this, right, negative 8, you always factor that out. Okay, so the GCF, when the first term is negative, is going to be negative. So when I think about my GCF here, right, first I set equal to 0 and solve. Sorry, 0. I'm going to take out a negative 2 and x. 8 and 6 both have 2. X squared and x both have x. So I get positive 4x minus 3. Okay, so be very careful when you're doing these. If it helps you to write them out like before, right? But like if I have negative 8x squared and I divide by negative 2x, I get positive 4x. And if I have positive 6x divided by negative 2x, I'm left with negative 3. Okay, so be very careful with your factoring, but you have to factor out a negative if it's your leading coefficient. Set each piece equal to 0 and solve. Okay, this one, some of you may have noticed, like sometimes you can just, if I go back up here, x plus 5, the 0 is negative 5. Maybe you noticed that. Okay, when it's like this, it doesn't work like that. Okay, I need to add 3 to both sides and divide by 4, and I get x equals 3/4. Okay, so this one's going to be a little harder for me to graph. I have one at 0 and one at 3/4. I can't actually find where 3/4 is, but I'm going to do my best to just kind of put it on there. Okay. You can use the decimal of this if you want to find the x of the vertex. Remember, I'm going to find the average. So 0 plus 3/4 divided by 2. I've got my graph over here.
Do I have to take the test too?
Okay, so 0 plus, you can just type it in like this. Whoops.
That's easy.
And then divide by 2. So this is 3/8 if you'd like to write it like that. Okay, to find it, this has a negative leading coefficient, so it's going to be a frown. Hopefully you remember that. If you don't, I can show you on Desmos, but I'll go -8, 3/8 squared, plus 6 times 3/8, and I get I get 9/8 as my vertex, 3/8 comma 9/8. Again, that's going to be super hard for me to graph. I'll do my best. I'll pretend that it's like right here, and this makes a nice upside down frowny face picture. All right, this is it for the notes today. I will try to get the answer key up for the homework as well, and I will hopefully see you guys tomorrow.